All right, hello, I'm Jan-Simon Möller, and I will present some updates on the continuous integration and automated testing side, and on some infrastructure updates that we are doing. Feel free to reach out by email, or you find me on libera.chat. There is the channel hash automotive where most people hang out. So next I'll talk about CIAT. I'll give some infrastructure updates. I'll give you some updates on the Yocto Project Kirkstone release that we are updating to. And I'll tell you a bit about new features and about software bill of materials and how we make possible to create them. So first, our CIAT infrastructure is built to take any change that we upload to our garage server. We'll build a set of artifacts, and then we will put them onto a test farm so we can be sure that any change that enters AGL is being tested, and we know that the boards can boot to a graphical screen and we can execute tests. And the benefits of that approach is that we do not need to ship boards around the globe to a lot of developers, and also developers can easily test on multiple boards. Yeah, so you can have one board on your desk, maybe two, but once it's 7, 8, or 9 different boards, that's more you can handle. And that's why we decided to set up this hardware lab. Also, we can test our software components on every change automated. That means no SD card juggling, no user interaction. And that allows us to produce a very stable AGL UCB platform, and also have multiple images for the different expert groups. So now I want to invite the expert groups to add their specific tests. So we can now, for the IVI PR side, we can add test scripts to exercise the infrastructure. Same with IC and Vertegy, to make sure that these profiles do work throughout updates that enter AGL. We have a CIAT call every other week, where we join to enhance the infrastructure and the test side. On the infrastructure side, we do have new things that we can do once we upref to Kirkstone. We have worked with the Yocto project upstream, and kudos to Scott, who did the work, and also Paul Barker did some of the work. So we saw the need that we have to share the so-called data of the PR server. This is something that currently runs in our CI and is part of the build process, but we need to publish this data. There was no read-only variant, so we helped upstream do that. Yocto project did also introduce a new concept, and that's Hashequiv. And in short, Hashequiv means if the binary output is the same of a build with a pre-existing build, then we can say that whatever sources or configuration change basically did not lead to a binary, to a change in the final binary. That helps to speed up kind of the build chains, because if there is no binary change, we basically do not need to rebuild anything that depends on that. So this will speed up the build process. Essentially, we will get a set of three. We will set up the read-only PR, the read-only Hashequiv, and we have already our public estate. And this will reduce build times. On the horizon, with these in place, is then also to have a binary distribution. Essentially, there is then a repository of binary artifacts, and instead of building, you just use an imaging tool to pull an image together from these. There's a work group that we participate in within the Yocto project, and that's the binary distribution work group. They meet next week, Tuesday. So let me give you a quick update on the Yocto project in Kirkstone. Up to Marlin, we use Yocto project Dunfell. That's an LTS upstream, and it has been extended in its lifetime, and we will support these mainly on the Lamprey branch and on Kirkstone, and on Marlin. The Yocto project Kirkstone release is basically to be released very soon, and we will merge that onto our master branch. So that's happening just now. Let me highlight a few new things that come in with Kirkstone, and mostly I stole these from the release notes, but let me highlight a few that you will come across once we merge the new release. There have been changes to the variable names to be more inclusive. So that's the inclusive language changes. We had a few changes to the source URIs. And one important change is the network access from tasks is now disabled by default. What does that mean? I'll explain in a bit, but this will be an important change, and I'll tell you when that applies. The license definition have been changed in the recipes to be now SPDX identifiers. And we'll see in the SBOM section why that was done and is necessary. The Python package build process got a major overhaul, so that's now all built, all based on wheels. If you are still using Ubuntu 16.04, this is no longer supported host distro. So for Kirkstone, we need at least 18.04 or 20.04. 2204 is not released, so that or is released in the same time frame essentially. So that's probably not one of the tested distros. And the public Hashequiv service is also new. Inclusive language, basically a lot of variable names changed from a white or blacklist to, well, they were renamed to more meaningful names. You might see that, or you might find out about that once if you are doing your own layer. But Yocto will warn you about one of the variables being deprecated. Default branch names have changed. So instead of master, a lot of projects now use main or even dev. And that means we cannot guesstimate for the main branch to be quote unquote master. And that means for going forward, we have to specify the branch down here in the source URI going forward. Also, if things are on GitHub, we need to use protocol HTTPS there. Okay, so the network access. It currently applies to CentOS 8 and Debian 11 and onwards. So that means quite recent distributions, which have the recent kernel and the infrastructure to do this. But it means going forward that essentially no task but the fetch task can access the network. And the reasoning is that we want to catch things that, well, go out and do something, fetch something in stages of the build where it shouldn't. This will affect you if there is some, for example, submodule fetching, or if in the build process there is some stuff done in configure that accesses the network. So watch out for that. There is a workaround, but we should rather fix the root cause. License definitions now use the matching SPDX identifiers. To simplify that, there is a conversion script. Also, if you embed a Python package, or if you have to create a new Python package for a dependency in case you need it, you have to use a new build process using wheels. Just look at the current examples. I mean, all the infrastructure are there to do this now. Essentially, it's just shuffling or changing a few lines in the recipe. So we already have a shared state cache that's filled by the CI builder. But to make this even more useful, we will introduce the PR, the read-only PR and the read-only Hashequiv service. Essentially, what does that mean? If your network connection is faster than you would be able to build the recipes, you can speed up your builds by downloading the artifacts. And that's even, that is basically supported by the read-only PR serve and read-only hash serve, because we can then reuse more artifacts. We'll introduce these settings soon, likely as an add-on, not by default. So if you want to use it, you have to opt in. Okay, and finally, let me explain some more about SBOM. So software bill of materials is kind of a list of what ended up and what relationships exists of the software that we put into the final image. And going forward, this essentially will be mandatory. We already do support this. Yocto already had manifest files that listed what is in the image. Essentially, that information is now enhanced. There is a new class, create-spdx. And with this, you basically can create all the information that you need for an SBOM. We have different types or different ways to do this. We have the Yocto built-in SBOM generation with create-spdx. This happens essentially during the build. We have support for uploading to external servers like Fossology. There, the scanning happens on a dedicated server. So outside of the build flow, it takes also quite long, or it's quite CPU and disk hungry to do the thorough scanning. For Fossology, we'll end up with essentially all the files scanned, and in the end, we need to triage things. And there's also Meta SCA, which has even more options. But note there's a discussion how to maintain this layer going forward. There are some changes in the maintenance going on. So the most straightforward way right now, since Kirkstone, is to use create-spdx. And it's also quite easy. You just inherit the class. What does that give you? Basically, we already have a license declared in every recipe. It's a mandatory field, so every recipe has to have a declared license. On top, what has been added is a quick scan for SPDX license identifiers in the source files. And that's why also the change of the license variable to be an SPDX identifier. So what we can do right now in Yocto is during the build, we can do, well, A, take the license from the recipe, and B, we do a very quick scan, basically top of file for the SPDX license identifier, and then see, okay, declared license, scanned SPDX identifier, they are equal, okay, everything fine. Otherwise, we'll get some warning about additional license identifiers. So this is a very quick and good way. If you need more thorough scanning of everything that's in the archive, then you will have to go to the external methods like Fossology. Okay, that's all. Thank you for joining AGL Tech Day, and yeah, back to you, Dan.